I'm incredibly excited today to talk to you about a new feature for advanced data scientists called Composable ML. So let's start with the good old Lending Club dataset, where we predict whether someone is likely to default on a loan, using features such as loan amount, interest rate, loan purpose, and so on. Autopilot has already completed, and we can see that DataRobot built and tested 88 models. These are a mixture of traditional tree-based linear algorithms and the latest deep learning algorithms. This XGBoost model was the winner and has been recommended for deployment. Opening up the model, I can look at the blueprint. This is a machine learning pipeline that has been used to train my model, and it includes pre-processing as well as the modeling steps. Now, as an advanced data scientist, let's say I want to try out a custom missing values imputation technique, compare results, and deploy the best model into production. To create my custom model, I'm going to follow 3 steps. First, I'll write my custom missing values imputation method. Next, I'll upload my code into DataRobot so that it can be used as a step in a blueprint. And then I'll use my code to build and train a new blueprint. Here is the missing values imputation task I've defined in Python. To make sure DataRobot can correctly run my code, I've defined 2 hooks, fit and transform, where I specify how the task learns on training data and how it applies the learnings to transform new data. I've also added a task schema to validate tasks' inputs and outputs when building a blueprint. The next step is to import this code into DataRobot so that it can be used as a task in a blueprint. I click Add New Task, a transform in this case, and give it a name. Next, I'll pick a container environment in which to run the model. I'll use this Python 3 scikit-learn environment provided by DataRobot, but I could define my own Docker file and install any dependency if needed. Now, I upload the code. My task is now defined and can be used for modeling. Back on the models page in my project. Here I'm going to copy my winning blueprint to use as a template with my new missing values imputation task. The steps in my clone blueprint are now editable, and I can add, remove, or replace any step in it, or build a completely new blueprint. I remove the old missing values imputation task and add a new one. I can now choose from a huge list of transformations and estimators available for me. For my project, I'm going to replace the missing values imputation task with the one that I've just uploaded, but I could also use one of the built-in tasks instead. I can continue modifying this blueprint, for example, by replacing the text pre-processing task with TinyBird. Now, let's train our new blueprint. The model is now being trained in DataRobot. We sped up this process to save some time. After training, my model appears in the leaderboard, where I can see how well it performed against other models in the project. Here it is. I can now start benefiting from other awesome features that help me gain productivity and save time. As I continue iterating, the leaderboard will track the models and their accuracy so I can explore what works and what doesn't for my specific use case. I can save my blueprints into AI Catalog to reuse it later or share with my colleagues. I can access model-agnostic insights, for example ROC curves or feature impact, that can help me debug and further improve my model. I can leverage automated compliance documentation to save time otherwise spent on manually creating model documentation. And, of course, I can also deploy my model into production in just a few clicks. This means the model will get highly specialized monitoring, governance, lifecycle management, and retraining, all on our world-class, enterprise-grade MLOps platform.